thank you everyone for coming. It's great to be here. As you can see, I'm from Australia. This is my first time visiting Canada and my first time in Montreal. I just spent the weekend here and it's a lovely city, so thank you for having me here. As I was introduced, my name is Linda and I am from an organisation called Tyre Stewardship Australia, and I'll tell you a little bit about that when I get into my talk. But today I'm really talking about a lot of the work we do in our organisation around tyre resource recovery, environmental impacts and some of the challenges along the way. So tyres are a relatively essential product, or pretty essential product in modern mobility. It's likely that you took some form of transport to get here using a tyre. The materials that you're using were transported to you using tyres. This afternoon will be going on an aeroplane that has tyres. So they're everywhere. They're the material that we all use all day, every day. And so it's pretty important that we understand the environmental impacts that may be produced from their use. So today I'm going to talk through a number of different stages of a tyre life cycle. I'll begin with just an introduction on tyres, give you a little bit of context for the challenge in Australia, as well as our organisation and how we're working to address those challenges. Then I'm going to step through tyres in different stages, so environmental impacts in use for tyres, as well as at end of life, and then finally in recovery pathways, so as we reintroduce them back into new uses and into the circular economy, what are the impacts there? And then really wrapping up the talk, I'll be trying to bridge the gap and have a conversation about how we can work across the value chain to really understand these impacts and address them. So the scale of the issue, how many tyres are there in the world? So at Tyre Stewardship Australia, we do a lot of work around data and numbers to understand the volume of tyres in Australia. So in Australia, our end-of-life volume, so how many tyres are generated each year from being changed, is 537,000 tonnes of these tyres. So that's, if you're thinking about like a size of tyre, for example, like a normal car tyre, that's about 65 million car tyres. But in Australia, we have lots of different sizes of tyres, as we do in Canada. In particular, we have a large number of off-the-road tyres, so the big mining tyres that are as tall as this ceiling. Canada and Australia are very similar in a lot of the tyre types that we have, and the types of mining and the types of production that we do. And the size of our countries as well, similar sized countries. So around a third of our tyre volumes are off-the-road tyres, and then the other 2/3 are the on-road tyres, so passenger, truck, bus, automotive vehicles. In Australia, we split into states, just like provinces in Canada, and so depending on where you are in the country will dictate what types of tyres are there, because some are more agricultural regions and some are more mining regions. And this data is incredibly important to understand the types of activities that we do in different places around the country. So, for example, on the West Coast, there's a large number of mining and off-the-road tyres, and so a lot of our activities are focused on that particular sector in that region, because that's where a lot of the challenges are. And then I've just put up some information about globally where all the tyres are. So you can see it's maybe a bit faint, but 25 million tonnes of tyres. So that's a large volume of tyres. These numbers are a little bit older, but really this map shows not just the volumes of tyres, but some of the locations that those tyres are ending up. So for example, in engineering applications, energy recovery applications, so used as a fuel in cement kilns, material recovery, so used in softball playgrounds or in asphalt roads, and then others, so not recovered, whether that be landfilled, stockpiled, buried. So the numbers are really important because they help us to understand where the environmental impacts are likely occurring and where interventions need to happen. And so a great way of understanding where those interventions or those conversations need to happen is looking at a framework called a circular economy. So if you haven't heard of the circular economy or the framework circular economy, it's really based on 3 key principles. Firstly, eliminating waste and pollution. Secondly, circulating products and materials at their highest value for as long as possible. And then the third principle is really regenerating nature, so building back biodiversity. And so I've put up a diagram on the right side that sort of maps what that looks like for a tyre. So tyre in use when it reaches end of life and how we recirculate those materials, as well as the disposal pathway, how we minimise or eliminate that disposal at end of life, but also, you know, all the way along that life cycle. So why is it that I know all this information, and why, you know, why is it that we're interested in the tyre circular economy? So I work for an organisation called Tyre Stewardship Australia. So Tyre Stewardship Australia is an organisation and we run our product stewardship scheme in Australia. So our core mission and our core value is really maximising the value of resources in tyres. So how can we maximise their value all across the life cycle of tyres? We have a number of different ways that we do this, a number of different strategic programs. We do a lot of market development funding, so invest in new markets for end-of-life tyres. We've been around for about 10 years now, a bit over 10 years, and in that time we've invested over $11 million across 70 different projects across Australia. And so these projects would be looking at either university-based projects, so, you know, whether it be in civil engineering or in environmental engineering, building new information and new knowledge, or taking that research into the field, so doing trials and demonstration projects, helping support industry to really commercialise those new products or overcome barriers to those products getting into the market. We also work in an accreditation space, so we do accreditation, compliance and auditing of recyclers, collectors and retailers of tyres, just to ensure that those connections between those stages of the supply chain are really managing tyres appropriately. So by participating in our scheme, those recyclers and collectors will be audited each year to make sure that their materials, they're doing what they say they do, and what they're supposed to be doing. And also a lot of our data and information comes from those participants. By participating in our scheme, they help to build that data that you saw on an earlier slide. And then finally, awareness and education on issues and opportunities for end-of-life tyres across the value chain. So really, whether that be consumer awareness, so helping consumers to understand where they can take their tyres back to ensure that they're managed appropriately, or whether that be awareness to government to enact better policy decisions, or whether that be working with local councils or local manufacturers to really understand this challenge and why, and how you can get on board and how you can really support this endeavour. So that's our organisation. I'm the science, I lead our little science team at the organisation, so we support a lot of the market development work that's done, so help support universities to get the right information, and then also try to build good information around other topics. So you're talking about electric vehicle tyres and how that's evolving, an evolving space, and so how do we build more information and understanding to help the sector to adapt and change to suit new conversations and new tyres. So stepping through, I guess, this conversation about environmental impact, I've put the circular economy diagram back up because it's a great framework, but also because there's also value in talking about the waste hierarchy. So the waste hierarchy is a framework that's been used for a very long time to understand the best pathway to manage waste, and so what the most optimal pathway for different waste materials. And so you can kind of combine them together and understand we have a waste hierarchy that looks at how we avoid waste, how we repair and reuse and recycle materials, as well as recover them if they can't be repaired or recycled. And what I've done is we've worked to link them together. So how do we frame them to ensure we understand what their circular outcomes are as well? So how circular are these materials? Because in a circular economy, you want to recirculate the materials, but at their highest value. So how do we map not just recycling as one kind of type, singular entity, but actually it's a spread of, like, not all recycling is the same. And so a circular economy really helps to understand, different types of recycling and different stages of recycling. So when we think about environmental impacts, and we'll start with the beginning, so tyres in use. A big environmental impact of tyres in use is what's called tyre and road wear particles. So this is a big global conversation that's happening. Tyre wear is ubiquitous to all tyres that are made of rubber. They will wear out and they will produce fine microparticles. It's caused by friction and heat and the force from abrading tyres against a surface. In the case of automobile tyres, it's on the road surface. And generally there'll be a mixture of the tread as well as other road surface material, dust, paint, asphalt mixed in. These particles are being widely studied across the world to understand them better. They've been around for a very long time, but it's really only in the last maybe decade that they've had a bit more focus put on them. And these recent studies are showing that they're of a size range, a broad size range, but the sort of most particles are in the 100 micron region. Recent studies have found that in Europe, a tread mass generation of approximately 1 kilo of tread per person per year. So a lot of materials ending up in the environment. And a large proportion of this material is ending up as microplastics across the globe. So this is obviously a large and major issue. And so when we think of a circular economy, I guess the first thought or the first step would be, well, how do we eliminate this from happening in the first place? How do we design this out of tyres? If we don't need to be generating these microplastics, how might we do that? And so that to understand what that looks like, you need to understand the design or the chemistry of tyres and how they're manufactured and what properties are important to tyres. So I've put up a diagram of what's called the magic tyre triangle. These are 3 of the major important properties of a tyre. And so when you mix rubber compounds together and design a tyre, these tyre manufacturers are designing them in a way to optimize these 3 properties. So the first one being rolling resistance, so the resistance to rolling, and that's a property that's really strongly linked to fuel efficiency. And so the higher the rolling resistance, the lower your fuel efficiency, the more fuel you need to push the car along. And so manufacturers are looking at ways to adapt tyre design to lower that rolling resistance and get more efficient vehicles using tyre design. Then we have the property called wet grip, which is the ability to grip in the wet, which is very much a safety property. And so wet grip is an important property that they want to optimize in the design of tyres. And then abrasion resistance. So this one is the one that's linked to tyre wear. So if you have more abrasion, so a lower resistance to abrasion, then you're going to generate more tyre wear. And so to minimize tyre wear, you want to increase your abrasion resistance. Now, tyre rubber compound chemistry is very complicated, and you can't change one of these properties without impacting the other properties. And so because everyone's talking about vehicle efficiency and everyone really cares about the safety of their vehicles, abrasion resistance is kind of taking a back seat. And so often what happens is manufacturers will be optimizing these other 2 properties and then not focusing on abrasion resistance. Or if they are looking at how do we increase or improve abrasion resistance, often it reduces the impact from the other two. And so it's a complex issue, but in Europe, for example, they're looking at introducing new regulations on tyre abrasion, and so limiting the amount of abrasion so that at least the property is optimised in tyres. And that's just one example of where they're looking at it. But this is, I guess, a global conversation. So it's a bit tricky. The other challenge with tyre wear is not just the generation of the wear, but the impact it then has on the environment. So these small microparticles not only are pollutants, so they're microplastics that are ending up in the environment, but the chemicals that they contain can also impact the surrounding environment. So about 5 years ago, there was a study that came out that linked what was a long-term mystery on the west coast of North America with a species called the coho salmon, where the coho salmon were just unexpectedly dying before they could spawn. And it's been happening for a very long time, but it wasn't until about 5 years ago that it was directly linked to a chemical that was present in tyre particles. And so the chemical is on the left-hand side, it's called 6-PPD, and it's an anti-ozonant that exists in tyres, and without it, tyres would basically fall apart. So it's a very essential tyre chemical, but unfortunately, when the tyres wear and these particles end up in the environment, and then these particles then further react, they generate this quinone form of 6-PPD, and that is extremely ecotoxic to these coho salmon. And so they found what the problem was, but unfortunately, at the moment, there's no sufficient alternatives to this chemical. So this is another step in the right direction to understand, well, what are the alternatives that can be put in these tyres so that they aren't causing mass death. In Australia, we don't have large populations of coho salmon, but there have been Australian studies that have linked it to pretty important fish species like our rainbow trout and our brown trout. And so it's very important to Australia as well, not just the west coast of North America, that an alternative is found for this chemical. And then finally, another conversation is, okay, if we're going to acknowledge that we're still trying to find an alternative, and if we're going to acknowledge that tyres, until we stop using them made out of rubber, they're going to wear, well, what are the solutions to capture and contain and mitigate these particles ending up in the environment? So a lot of work being done by a global organisation called the Tyre Industry Project is really working to fund and communicate research that's trying to address these different pathways into the environment. So a large amount is ending up in soil, but also, you know, the material that is flowing into different environmental compartments. They're working on solutions for that, whether it be road cleaning surfaces, whether it be collection beds on the side of highways. So I don't have an answer to this question. It's a very complex global issue, but hopefully you have a bit of an understanding of some of the initial environmental impacts from tyres in use. Then we move on to the next stage, which is end-of-life tyres. So once these tyres are changed and no longer used on a vehicle, so tyres can be retread or reused, or there's other ways to repair tyres, but if they can't be repaired or retreaded, then they reach that end-of-life stage. And that next step is really the collection of tyres. Now, collecting and recycling tyres is an expensive endeavour, and often we see this around the world where it doesn't quite line up, or something happens and tyres are stockpiled. And so stockpiled and dumped and lost tyres like this is a massive environmental impact of tyres. Not only because it's gross pollution and it would be even more expensive to clean up a stockpile like this, it's also a massive risk to the environment, safety, environmental risk. So this is a stockpile of tyres that is located out in the South Australian desert. So they're called the tyre tanks, and they've been in South Australian desert for decades. There's actually a picnic area near the tyre tanks called the tyre tanks picnic area. So they've almost become a little bit of a local, landmark. And it was just a mismanagement of tyres. So this is why a lot of the work that we do is really trying to avoid this mismanagement of tyres. Now, yes, it's a landmark out in the Australian desert, great, but unfortunately in 2023, these tyres caught fire. So not only were these tyres a massive loss of resource, gross pollution out in this very beautiful area of Australia, then they caught fires, and once tyres catch fire, they're very difficult to put out, and also the environmental impact from those materials is even drastically more. So the residual material going into the environment is incredibly hazardous and toxic, as well as the material getting all the volatiles that end up in the atmosphere. So obviously this is problematic, and this is something that we want to avoid, and that's where a lot of stewardship schemes come in. So Canada has stewardship schemes across the country to also help manage these types of, stop these types of events from occurring. And I think it's one of the West Coast schemes that actually started because of a massive tyre fire. So there was a massive tyre fire that happened, and basically the scheme was like, oh no, we have to avoid this happening in the future, and that's how one of the stewardship schemes actually became what it is today. So really important. And so how do we actually recover these tyres? What's the steps that are gone through to, once tyres are collected and not left on land, what happens? And that's this recovery step. So tyres, depending on their size, will be sectioned and shredded, and then that material, depending on what it's being used for, can be downsized further. So it's a very physical deconstruction process to get the material into smaller and smaller forms so that it can then be used in different applications. From a transport perspective, tyres are very inefficient to transport because they have a big hole in the middle. And so sometimes just sectioning it and shredding it is the ability to help transport the tyres. It's also helpful to then be able to use in further processing applications. So there's a couple of examples of secondary processing. So these are more thermal or chemical based processing. Pyrolysis is a thermal processing application. So often tyres are downsized to a particular size so that they can then be heated evenly in a pyrolysis reactor, and then produce different products that can then be used in other applications or further refined to be used. There's also there's upcoming devulcanization processes or growing devulcanization processes that are reaching commercialization. I'm actually going to Toronto tonight to visit a devulcanization plant there, and basically that's a process that reverses that vulcanization step. So tyres, when they're manufactured, the final step is a vulcanization step, which is cross-linking all that rubber with sulfur, and that's really what makes rubber its cured hard form. But it makes it really, really hard to recycle, because obviously we want it to be strong and durable and not easily broken down. And so devulcanization is quite a sophisticated or refined process to be able to target those sulfur bonds and not break down the whole rubber network. And then reclaim is another application where often like plasticizers are added to rubber to help the material or to help it be reformed or reblended into new applications. And it's a big, in like Asia, a lot of reclaimed rubber is being used in applications. So once we have these sort of tyre materials, so these downsized products or these further refined products, what do we then use them for? And so that's really what the market development process is. So we call it market development, but it's really like product and design of new materials. And that's where a lot of our focus and our funding has been in the last few years. So these are some of the key sectors that we work in. So roads, a lot of rubber in Australia is used in asphalt surfacing, civil engineering, so used in different concrete applications, manufacturing and mining. There's a couple done some initial research in rail, as well as different research, new innovative products that we're working on trying to get into the market. So one of these examples, and this is a really big area that we work in Australia, is looking at crumb rubber modified bitumen. So I know I'm talking to a room full of engineers, so basically I'm not going to tell you how a road is manufactured, but really the crumb rubber that we use is often modified in the bitumen, not added as a additive in the aggregates. And the reason for that is that the rubber modified bitumen has a lot of performance benefits that it adds to the roads. So the rubber improves the elasticity and the flexibility of the road, and that just provides lots of performance benefits, whether it be less cracking or less slipping or adhesion loss from the bitumen in the aggregate. And also a study that came out of Australia, the carbon black, so tyres are not just rubber, they're also carbon black and other additives in there. Because carbon black is a good UV screen, there was actually a study that we supported in Australia that looked at durability of different road surfaces from a UV perspective, and basically the rubber, because of that carbon black, is acting as a bit of a sunscreen for the road. It stops sun damage in the same way that a non-rubber modified bitumen would have. So that's a really interesting study if anybody wants to read it. But it's not just roads. Roads is a big area we've worked in, but another application that we've worked with is in concrete crash barriers. So we worked with the university to help. They designed the different mixes to understand the best volume of rubber added to these concrete crash barriers. And the main purpose of these crash barriers is impact attenuation, and basically by having rubber in there, it just improves that dramatically, because concrete obviously is very stiff. And so by having, I think it's about 4% rubber in the mix, there's a 10% higher energy volume. These slides will be circulated, but I encourage you to go look on our website, because there's a great video that we have of this truck running into a crash barrier. That was actually a test that we did and helped support to get that product into a road specification. So road specifications, very strict, and so they needed to do that test to prove that its performance met or exceeded a standard crash barrier, and that product is now a commercially available product. So that's really great. We work with concrete and cement. Rubber is not as performance enhancing from a strength perspective with concrete, because it's added as an additive rather than a binder modifier. But there are other benefits that rubber can provide. For example, the energy absorbance behaviour. There's also noise and vibration attenuation, and so we have clever people working in noise walls and in vibration applications to really see whether rubber can provide benefits there as well. So I promised I'd be talking about environmental impacts. So obviously we've got these great applications, they're performance enhancing, but it's important that they don't then have unintended or unnecessary environmental impacts in the long term, because we don't want to just redirect the environmental impact to something else. And so a lot of the work that I do in the organisation is really trying to understand this area and what types of studies we need to do to understand the environmental impact of these products. So first step is to say, well, they're different products depending on what size rubber you're using and what material you're putting it into. So a lot of the research and a lot of the information on environmental impact of tyres is at the tyre wear stage because there's so much of it and it's such an environmental disaster that so much of the research is there. But it doesn't necessarily directly correlate or transfer to these other products which are much bigger, often bound in a new material and often not exposed to the environment in the same way as tyre wear. And so I like this diagram because it just helps to visualize the different scale of these products that we're working with and communicate that we need to understand their impact in a different way. So roads, I come back to roads because it's a great example of like we've got tyres at the surface and now we've got tyres in the surface. And so your brain would maybe connect and go, well, it's problematic to put tyres in a surface because it's just going to exacerbate the issue. And so that's a conversation that we're engaging in and trying to understand better. So looking at what is the volume of the material actually added into the surface, what depth does it go into, and also what does the ability to wear on that surface, how much of that, so we have the tyre driving on the road, how much of that wearing course is worn and how much of that is now rubber. And so we've done some work with a university in Australia to compare different asphalt designs and look at different mixed designs, some that contain rubber and some that don't, to understand the volume of material that's being released and whether that is enough of a volume to be considered an issue. Similarly, we've looked at leaching and rainwater experiments. So again, looking at these different mixed designs, how porous those designs are and how much material is being lost. We've looked at the 6 ppd chemicals because they're obviously drastically being laser focused looked at, as well as other potential chemicals of concern, heavy metals, volatile compounds. And the results are quite promising for roads because it is such a small volume added to the material, and a lot of roads already have modified binders in them anyway, and so we're adding a different material but it's not causing a big enough change to the material to cause a large contamination issue. But those results are still being published, so look out for those results soon. And then of course it's not just roads, there's rubber that's used in bound surfaces, so in playgrounds, as well as in infill in different sports applications. And so really we did some work as well looking at those contamination levels in those recreational surfaces as well and compared them. And so again, there was nothing in there that surprised us and didn't look different to what had been done globally either. A lot of studies have been done on playgrounds and on turf already, and so what we wanted to do here was compare Australian tyres to international studies to make sure that our particular tyre mix wasn't drastically different, because we have such a large volume of mining tyres and we have a different ecosystem in Australia, so we wanted to understand those unique challenges as well. Okay, so I've taken you through lots of different stages of tyres' life cycle. We've talked about environmental impacts. And specifically, I've taken you through it from a circular economy framework perspective. And I want to come back to the principles which are eliminate waste and pollution, circulate products and materials at their highest value for as long as possible, and regenerate nature. And I come back to that because that's really the mission that we're driving towards. So every application that we look at funding, we consider those impacts, and every material that we work with, we want to understand it from this perspective. But I also bring it back up because a circular economy is a great framework to look at the whole tyre value chain, and we've talked about the environmental impacts at different stages, but we're talking about the same material the whole way along. It is all just tyres that we're talking about. And so it feels like at the moment we're trying to solve each challenge independently of one another. And yes, there are different materials and different products and different environments and different countries that we're working in. But actually, it's not that many different stages. And also, if we can fix challenges at one stage, if we're clever, we can ideally fix them at a different stage. So for example, from a design perspective, if you can design tyres to be more durable and last longer, that's really good for, for example, new products at end of life. If you can change the design to make a tyre more durable, it could be a better performance enhancer at end of life. But you have to do so in a way that you're not then going to make it even more challenging at end of life. So I use the example of different additives that are being added to tyres, which are like sticky liners, so that if a puncture happens, the tyre then lasts longer. So if there's a puncture and you pull it out, it'll just put that sticky polymer liner back in. But you're adding a whole new material to the supply chain, and it makes it really, really difficult to recycle those tyres. And so yes, you're extending the life of that tyre at the beginning of its life, but you're actually potentially making it not recyclable. And so that material is then going to have to go to landfill or not be recovered in the same way. And so the designers have to be not just thinking about the first life, but those second life. If we can fix that 6 ppd issue in design, we don't even need to talk about it anymore at end of life, because we're only ever using tyres that have already been in that first life cycle. So if we're eliminating those tyres from there, then we are solving that issue at end of life. It may take 5 to 10 years to come into effect, but it can be solved. From a use perspective, if we're coming up with solutions to be able to capture and contain tyre particles at a road surface, again, these materials are often used at a road surface. And so if we're coming up with collection beds, can they be applicable to tyre materials that are also embedded in concrete and are also embedded in asphalt? And so I guess from my perspective, there are a lot of challenges along these different stages, but they're not in silos. If we can help understand and talk to different stages, we can potentially address them at all these stages. Yeah, I think that's all I had to talk about today, but I'm happy to take any questions. Hopefully I didn't talk too fast.